Checkpoint 5. The figure shows three pairs of parallel plates with the same separation, and the electric potential of each plate is mentioned in the diagram, in the figure. The electric field between the plates is uniform and perpendicular to the plates. Question A. Rank the pairs according to the magnitude of the electric field between the plates greatest first. Question B. For which pair is the electric field pointing rightwards? And question C. If an electron is released midway between the third pair of the plates, does it remains there, or move rightward at constant speed, or move leftward at constant speed, or accelerate rightward, or accelerate leftward? So we have to answer for these three questions. First of all, let's see the given figure. What is given in this figure? They gave two parallel plates with potential value. So you can see this plate, the first one, what I just mentioned with my pen, this is the plate 1, this is plate 2. Likewise, this is plate 1, plate 2, plate 1 and plate 2. So the plate potential is given, right? And also they mentioned the distance between these two plates for these three diagrams are same distance. So let's consider the distance here. They mentioned d, okay, because they mentioned a same separation. Clear? And the potential difference is given. So what is the potential difference between these two? Because the electric field lines move from higher potential to the lower potential. So here this is the higher potential plate, and this minus 50 is the lower potential plate. And also they mention between the plates the field strength is uniform, and also it is perpendicular to the plates, means it is moving exactly perpendicular to the plates. So that means if you see here, this second plate is highest potential, that means the higher potential, and this one, first one, is the lowest potential. So your electrical field lines is pointing from positive direction to the negative direction. Am I right? So this is the direction of the electric field for the first pair of the plate. Likewise, for the second one, you can see this is the second one, is the 200 is the greatest value. So greatest to the smallest value, the field lines will be moving. So again, the field line direction is moved from 200 volt to minus 20 volt. And then for the third, we have two plates with a negative number. So here this is minus 200 volt, this is minus 400 volt. So out of this, which one is the greatest? Minus 200 is the greatest, right? So that means your electric field lines is moved from this minus 200 volt to minus 400. Clear? This is the higher potential, this is the lower potential. So now we have to answer the question one by one. So now what we are going to do, rank the pairs according to the magnitude of the electric fields between the plates greatest first. As we know, the difference, the relation between the electric field and the potential. What is the formula? Electric field, which is equal to minus delta V over delta X. It's the rule. This is the relation between electric field and the potential. Now I am going to apply this rule for each figure. So let's apply this rule for the first figure. So you can see electrical field, which is, so let's consider the magnitude. Okay, so if you consider magnitude, then this will be gone. So we are going to consider only the magnitude. So delta V, what is delta V? 150 minus this one, because delta V2 minus V1, so that means this minus this one. So 150 minus of minus 50, and the distance, delta X distance between the two plates is d. So we can write like this. So 100 minus into minus become plus. So what is the answer here? 200 over d for the first. Likewise, I have to do the same thing for the second one. So here for the second one, magnitude of the electric field, which is equal to 200 minus of minus 20. 200 minus of minus 20 over d. So here we got 220 over d. And then we have to find the answer for the third part. So better I can write the answer here. Third part I can write it here. So magnitude of the electric field E, which is equal to greatest minus smallest. So here minus 200 minus of minus 400 over the distance is d. So here we got minus 200, minus into minus become plus. So we got 200 over d. So this is the answer for electric field after we apply this relation. Clear? After we apply this relation, we got the answer. Now we have to rank. rank from the highest, the greatest first. So if you see, the second electric field is the greatest. So we can answer, how we can answer? The second one has the greatest value. So 2 is greatest, and then 1 and 3 has the same number, so we can write 1 which is equal to 3. So this is the answer for part A. Clear? Now in the second part B, in which pair the electric field point rightwards? You can see here in the first pair the electric field lines pointing leftward direction. In second diagram also it is leftward direction, but in the third the electric field is towards the rightward direction. So we have to answer for part B, for which pair is the electric field pointing rightwards. Which pair? So the third pair, am I right? So the third pair, so the answer for B part, the third pair gives the electric field rightward direction. So here the electric field rightward direction. So the rightward direction is the third part. So this is the answer for second question. And then we have to answer the third one. So if an electron is released midway between the third pair, you can see here the electrical field lines are moving towards the rightward direction. So in the midpoint we are releasing the electron. So what will happen when you place an electron in the midpoint between the two plates? What will happen? The electron will experience the force opposite to the direction of the electric field. That means it will be moving this direction. Am I right? So it will be experience the force, means Newton's second law. Newton's second law, which is equal to F, which is equal to mass multiplied by acceleration. That means the electron will have the acceleration. Which direction? Leftward direction. So the answer here for the third question, which is C, the answer here is accelerate leftward direction. So the answer for the third question, electron will accelerate leftward direction. So this is the answer for this checkpoint. That's it. Thank you.